Imagine a chimpanzee, our closest living relative. It hoots, pants and screams, expressing emotion and warning, but these are not words. Now picture a human child, barely walking, babbling dada or ma. That child isn't just making noise, it's practicing, listening and copying the language around it. This is the great divide. Chimps have a fixed set of calls, while humans learn and refine sounds. A chimp in China sounds like a chimp in Chicago. Their calls are innate, not learned. They can express fear or excitement, but not abstract ideas or stories. Human children, by contrast, are vocal learners, absorbing, imitating, and building language. This ability, vocal learning, is the foundation of human communication. Without it, there would be no poetry, science, or whispered secrets. Chimps can signal danger, but can't explain or elaborate. We, the vocal learners, have broken free from the limits of instinct. On one side of a chasm, us, with our libraries and conversations. On the other, chimps, sharing most of our DNA, but locked in vocal silence. The sounds and desire to communicate are there, but the bridge, vocal learning, is missing. This isn't a failure, it's a clue. It points to a pivotal moment in our evolutionary history. Our brains took a different path, one that filled the world with words. That path is the story of how we became human, and it all starts with the urge to copy. For years, scientists thought our ability to speak came from our anatomy, specifically, our lower larynx. The idea was simple: our plumbing was special, letting us make more sounds. This theory dominated textbooks and documentaries. The assumption, even a smart chimp couldn't talk, because its throat wasn't built for it. But as technology advanced, researchers built computer models of chimp vocal tracts. The surprise? Chimps could, in theory, make many of the same sounds as humans. The old myth of bad pipes fell apart. The real difference wasn't in the hardware, but the software, the brain. Chimps have the instrument but not the musician. They lack the neural control to play their voice box like we do. This realization shifted the search for speech's origins from the throat to the brain. The secret to speech wasn't in our anatomy, but in our neural wiring. Our brains, not our throats, set us apart. The case was reopened. The question became, what's different in our brains? The answer would change everything we thought we knew. It's not the pipes, it's the plumber. If the brain is the key, why can parrots and mynah birds imitate speech but chimps can't? Parrots can mimic words, phones, even barking dogs, despite being distant relatives. Meanwhile, our close cousin the chimp is silent when it comes to imitation. This isn't about intelligence, it's about a rare, neural adaptation. Dolphins, whales, seals, and elephants can also learn new sounds. These species, scattered across the animal kingdom, all crack the code of vocal learning. Evolution found the same solution in different lineages, a case of convergent evolution. The talking parrot and the silent chimp show that speech-ready brain wiring is a special upgrade. It's not a given, even for smart social animals. Only a few species have it. The question is, what's their secret? To find out, we need to look inside the brain. The leading theory? Speech didn't require a brand new brain circuit. Instead, evolution duplicated an ancient motor pathway, a copy-paste error with huge consequences. Most mammals have a basic pathway for instinctive sounds, grunts, screams, reflexes. But in vocal learners, a second duplicated pathway emerged. This new circuit connected the thinking cortex directly to the voice box. Suddenly, conscious thought could control sound. The voice became an instrument, not just a reflex. This was the revolution. The birth of the will to speak. A simple duplication, a spare part, became the foundation for language. The brain's copy-paste moment changed everything. It turned noise into communication. This new brain pathway is the key to vocal learning. The old pathway is like a car horn, one sound, no melody. The new pathway is a synthesizer, endless possibilities. Now, when we hear a sound, our brain can experiment, adjust, and imitate. This feedback loop, hear, try, compare, refine, is how babies learn to talk and singers perfect their craft. The cortex has direct control over the voice box, translating thought into sound. Without this, even a brilliant brain can't produce complex speech. Birds, like parrots, and songbirds evolved their own version of this pathway. They too can consciously control and modify their sounds. Chimps, for all their intelligence, are stuck with the car horn. The dual pathway is the secret ingredient. It's what separates mimics from mutes. It's the neural leap that made language possible. The story doesn't end with speech. This brain upgrade gave us rhythm too. Only vocal learners, humans, parrots, elephants, dolphins can dance to a beat. Dogs and cats can't move to music, but parrots can bob to Queen, and humans dance everywhere. Why? The same neural system for vocal learning also handles complex motor timing. Speaking is rhythmic, so is dancing. The brain's timing machinery for speech spills over into movement. When our ancestors evolved this wiring, they got rhythm as a bonus. The cortex could now control not just the voice, but the whole body in time with sound. Speech and dance are two sides of the same coin. Both are rhythmic communication. One with sound, one with movement. Our brains were rewired to copy, and we became creatures of the beat. The urge to move to music is built into us. It's all thanks to the copy-paste brain. The vocal learning pathway is a central hub for timing and synchronization. It links what we hear with what we do. Learning to speak means matching motor patterns to sound patterns, requiring precise timing. The same system lets us dance. Music's beat is processed, and the brain sends timed commands to our limbs. That's why dancing feels natural to us, but not to most animals. Our brains are wired to find rhythm and move with it. The speech system's influence spreads to other motor areas, linking sound and movement. When you hear a beat, your speech network gets excited, and your body joins in. This explains why we gesture when we talk, and why rhythm is central to human culture. From poetry to dance music, our brains connect sound and movement. We became rhythmic beings, our bodies electric. The world's beat moves us, literally. All because our brains learned to copy. The copy-paste brain didn't just give us speech and dance, it made us smarter. In songbirds, those with complex songs are better problem solvers. Mastering song builds a cognitive toolkit, memory, planning, flexibility. Both song and problem solving rely on executive function, sequencing, adapting, strategizing. The more complex the song, the sharper the mind. This feedback loop likely shaped our own evolution. As our ancestors learned to control their voices, their brains grew more capable. Language required sequencing and hierarchy, skills that spilled over into tool-making and social life. Our intellect grew alongside our voice. The journey to language was a cognitive revolution. And so, we returned to ourselves, the talking, dancing apes. Our leap to language wasn't a grand invention, but a lucky duplication. A spare neural pathway let us copy sounds, synchronize to rhythms, and plan ahead. This upgrade made us mimics, and then creators. Could it happen again? Maybe, in some clever animal, evolution will copy-paste a new pathway. The story of our origins is a lesson in humility. We're not special by design, but by accident. We took an ancient movement system and turned it into language, music, and culture. We filled the world with sound and meaning, all from a simple act of copying. Our legacy is mimicry. We copied sounds and got language, copied rhythms and got dance, copied ideas and got culture. From a single brain pathway, a cascade of innovation began. We went from apes on the savannah to explorers of the cosmos. We are the apes who learned to copy. And in copying, we learned to create. That is the story of us. And it all began with the urge to imitate.